Greetings, beautiful people. Welcome back to Find XYZ. If you are new to this channel, please subscribe. If you are not new to this channel and you have not subscribed, please subscribe. Let's build a community of learners together. We are still on the road to WASSCE 2026. Let's try this question. In triangle PQR, we have point R to be negative 2, 3, vector PR to be 4, negative 5, and vector PQ to be 7, 2. If we have 2 points, point T and X, as midpoints of vector QR and vector PR respectively, we've been tasked with determine the coordinates of points P and Q, and also to show that vector ST is parallel to vector PQ. Let's begin by sketching our triangle. So we have point P, point Q, and point R, and we have been given point R to be negative 2, 3. We don't know point P, so we'll label that as X, Y, and we also don't know point Q, so I will label that as A, B. But we have two vectors, vector PR to be 4, negative 5, and vector PQ to be 7, 2. Now, since we are looking for points, it means that we can make use of position vectors and express these vectors as position vectors. So we can express vector PR as position vector. So P to R, we can decide to move from O to R minus O to P. So we are going backwards. If you are starting from R, we are going back to P. So that is why the negative. And then also we can express vector PQ as position vector. So we have OQ minus OP. This will help us find coordinates of point P. So we know vector PR is OR minus OP. Then what is vector PR? It has already been given as 4, negative 5. So we substitute that, and vector OR is given as negative 2, 3. Now this is a position vector, so we write it as a vector. Then what is OP? We don't know, so X, Y. We can decide to send OP to the left hand side. This is negative, so we have XY now positive. Then we maintain this, which is vector OR, negative 2, 3. Then we subtract because we are moving to the opposite side. That is 4, negative 5. How do we operate on vectors? For vectors, we operate on corresponding components. So we are going to operate on the horizontal component, and when we are done, we operate on the vertical component. So we can write this as minus 2, minus 4 for the horizontal component, and 3 minus negative 5 for the vertical component. Let's operate them. So negative 2, negative 4 will give us negative 6. Then negative multiplying negative, that will give us positive. So we have 3 plus 5, that will give us 8. So it means that our vector OP is negative 6, 8. Then it means that our point P is negative 6, 8. Then we can also find point Q. The same way we apply position vectors, we are going to do the same thing to find point Q. So we can write PQ as OQ minus OP. Now we know vector PQ that has already been given as 7, 2, and OQ, we don't know what is AB, minus vector OP, which now we know what is OP, negative 6, 8. Then similarly, we can move this vector because of this negative sign. So we have vector PQ as 7, 2 plus, this is minus, right? So we have negative 6, 8 is equal to vector OQ, that is AB. The same way, we are going to add corresponding components. So we have 7 plus negative 6, then we have 2 plus 8. This will give us vector OQ, that is AB. So what is the horizontal component? That is 7 plus negative 6. So this will be the same as 7 minus 6. That will give us 1. And then 2 plus 8, that will give us 10. So it means that vector OQ is giving us 1, 10. So let's write it here. Now we have point Q to be 1, 10. So we have been able to find the first part of the question, which is determining the coordinates of point P and Q. And we have also been told that if point T and S are midpoints of QR and PR respectively. Now point T is mentioned first and vector QR is also mentioned in terms of the vectors. So it means that point T will be on QR. So we locate point T, which is a midpoint on vector QR. Then similarly, point S is also on PR. So locate a midpoint and label this as point S. Now let's connect these 2 points. So ST and then P to Q, because we have been asked to show that vector ST is parallel to vector PQ. How do we show this? Before we can show that, we need to find point T and then point X. Then we'll use point T and X to find vector ST. So let's begin. So we know point R to be negative 2, 3, and point Q to be 1, 10. Since T is the midpoint of R and Q, we can find the midpoint T. So we know it's x1 plus x2. We divide it by 2 because it's the midpoint halfway. Then y1 y1 plus y2 divided by 2. So this will be the horizontal component and this will be the vertical component. So we label this as x1 y1 and this as x2 y2. So we add the horizontal components together, we divide by 2. Then we add the vertical component together, we divide by 2. So we have minus 2 plus 1 all over 2 for the x component, and then 3 plus 10 all over 2. So minus 2 plus 1, that will give us negative 1 over 2. Then 3 plus 10, that will give us 13 over 2. So we have negative 0.5 and then 6.5. This represents point T, which is the midpoint on vector QR. So this will give us negative 0.5, 6.5. Similarly, we are going to find the point for x, which is also on point P and R. So what is point P? Point P is also giving us negative 6, 8, and point R is giving us negative 2, 3. I'm going to apply that same thing. This is x1, y1. This is x2, y2. So we are going to focus on the x and then we are focusing on the y. So let's put the x's together. Negative 6 plus negative 2 all over 2. Then 8 plus 3 all over 2. Simplifying, negative 6 plus negative 2 will give us negative 8 over 2. And then 8 plus 3 will give us 11 over 2. So this will simplify to be negative 4, 5.5. This represents the point S. So let me also write that one here. We have point S to be negative 4 and then 5.5. Since we have been able to determine point S and T, let's find vector ST. So vector ST can be written as OT minus OS. And what is vector OT? Point T was given as negative 0.5, 6.5, negative 0.5, 6.5, minus OS, which is given as negative 4, 5.5. So we can operate on corresponding components. This will give us negative 0.5 minus 4. Then we have 6.5 minus 5.5. So vector ST is equal to negative multiply negative, this will give us positive. So we have negative 0.5 plus 4, that will give us positive 3.5. And then 6.5 minus 5.5, that will give us 1. So it means that vector ST is 3.51. So we want to determine whether these two vectors, that is ST and then PQ, we want to determine whether they are parallel. So since we have been able to find vector ST, we'll compare it to vector PQ. Then what is vector PQ? 7, 2. So vector PQ is 7, 2. How do we determine whether two vectors are parallel? Now, if I say vector A is parallel to vector B, it means that vector A can be expressed as a scalar multiple of vector B. Okay, so if one is a scalar multiple of the other, then it means that those two vectors are parallel. So can we express one of them as a scalar multiple of the other? Let's find out. So if we have vector PQ to be 7, 2 and vector ST to be 3.51, is one a scalar multiple of the other? Yes, because 7, 2 is, we don't know, a certain constant 3.51. So this represents vector PQ and this represents vector ST. Let's find whether one is a scalar multiple of the other. So K, whenever you have a scalar, it multiplies the horizontal component and also the vertical component. So we have 3.5K and then K. Now, equal vectors, it means that we can equate the horizontal component. So we can say 7 is equal to 3.5K. We divide this by 3.5. We divide this by 3.5. How many 3.5 are in 7? That is 2. Similarly, we can also see that for the vertical component, K is equal to 2. That means that 7, 2, which represent vector PQ, is twice vector ST, which is 3.51. Since we have shown one is a scalar multiple of the other, this means that vector ST is parallel to vector PQ. Thank you for joining me. If you found this helpful, kindly leave a comment, share this video to all your friends, and please don't forget to subscribe. See you in the next one. I'm out.